All right, everybody. GM, good morning. This is the last build in the open stream of 2024. I think I made the title 2025. Oh, man. What are you going to do? Can I fix that? Maybe I can. I'm going to edit that right now. Starting off the morning with a bug. All right. I don't know if that updates everywhere, but whatever. Okay. So today, I'm going to be building a subgraph for the app that was made on yesterday's stream. So I'm going to do a quick overview on the app. I'm going to talk a little bit about how we're going to use a subgraph and why. And then I'm going to just build out the subgraph. And I do have to hop off in 90 minutes. So this is ending in 90 minutes, like it or not. Yesterday, we went a little bit long with chasing down a bug. But no matter what happens, I'm logging off in 90 minutes. All right, so let's talk a little bit about the app, what it does, why we need a subgraph. We can talk a little bit more about like what a subgraph is too before diving in. So the app is a tipping app within Slack. So the way it works is whenever your coworkers or whoever you have Slack with does something for you nice, or want to celebrate something, you can give them a taco. You get 5 tacos a day, and you tip people tacos just by mentioning them and saying whatever you want to say, and then add a taco emoji, hit enter. And what that's doing is kicking off a process for an app that's listening for messages of tips and writing tips on chain. So you can see I sent the tip successfully. I sent 1 taco to this user. The person who got tips said they received a tip. They could see like where that message was. And you could also see on chain what happened. Like how did that get my gosh. Hold on, let me take a sip of coffee. My gosh. Okay. We wrote that transaction on chain on behalf of that user in Slack and sent an ERC20 token accordingly based on who they mentioned. And I think one of the really cool things about this app in particular is, we're giving the users of Slack Ethereum addresses, and we're doing that with smart accounts. We talked a little bit yesterday about Third Web Engines, the app. We have our Slack where we do our chatting. We have an app that listens for messages that are tips. And if it's a tip, we send that over to Third Web Engine. And Third Web Engine is built specifically, has a lot of built-in stuff that handle like smart accounts specifically. So I can give it a salt, which is like the user's Slack ID, and it will tell me what the Ethereum address will be. And I could use that to send tokens around. And we're doing all of that settlement on Base. Right now we're using Base Sepolia, but you could imagine that this could be any EVM chain. So what we're going to do now is talk about why we need a subgraph. So in yesterday's stream, we built out this like withdrawal capability. So I'll demonstrate what that does right now. Basically, like your tacos are that you're accumulating through tips are being sent to this smart account that we've spun up for you based on your Slack user ID. And if you want to withdraw those ERC20 tokens to a different Ethereum address for whatever reason, we gave you the ability to do that. So all you have to do is go to like the app, you type in the address that you want to withdraw to, how many tacos you want to withdraw to, and click withdraw. And then we handle the rest for you. I didn't give any like user feedback on what's happening there, but there is stuff happening. And let me just see, where is that? Just looking for that engine URL. There we go. Yeah, so we just did this 22 seconds ago. Look at the transaction hash. You can see 2 tips went to that address that I just specified. Okay, so all of that is working, and that's great. So we can't really foresee what people will use the ERC20 for, but we don't want to bind them to keeping their tokens in a smart account that we spun up for them. they should be able to take those tokens and do whatever they want with it. Now, the issue is your currently we're reading your token balance to determine how many tips you've received. If we ever want to make like a leaderboard of who's received the most tacos, and by the way, I'm going to play some music just so that my headphones don't shut off. So if we want to make a leaderboard of all the people who received the most tacos, currently what we're doing is we're reading the balances of these addresses, and that's essentially how we're making a leaderboard. But the problem is if you're withdrawing your tacos to a different address, then your balance changes, and it's not really indicative of how many tips you've actually received. Does that make sense? Also going to do a quick volume check here just to make sure. Sometimes I go live and my volume doesn't work. One sec. Does that make sense? Okay. Volume's definitely there. Okay, so how do we fix this? We fix it with a subgraph. So a subgraph is it's basically an application that is listening to events that are being emitted on chain, and then it's indexing, or it's saving those events in a database that you could quickly look up. You can, maybe you could aggregate data, whatever you want to do. You can essentially store events. So for example, we have a tip event. I'm going to store that, and that's what I'm going to use to determine how many tips you've received all time. That way you could move your tacos to other addresses, and we'll still know how much you've actually been tipped over time, because every time you get tipped, the contract emits an event, and we know that that's a tip. All right, so first thing is, let's look at the contract. And I'll show you the event that we're going to be using when we index the events. So it's this event right here, tipped. That's what we care about. So anytime that a user gets tipped, and now there's like there's two different ways you could do that. You could tip once, you could tip like one person at a time, tip many people at a time, but ultimately you get into this function here. And at the end, there's this tipped event that gets emitted. It has like the address, who it's from, and who it's like all these addresses where it's to, or sorry, there's only 1, 2, that's fine. To address, and then the amount, right? And so what we're going to do is we're going to make a subgraph that's going to aggregate this data from the tipped event, and we're going to essentially tally how many times you've been tipped. So there's a really, really cool app called Ghost that makes creating subgraphs super simple. So that's what I'm going to be using today. And another like shameless plug to Ghost, they're super helpful and quick to help. So I've made other apps with using Ghost before, and anytime I have a question or anything, the folks at Ghost are really really fast to help. So I'm going to stick with Ghost for now as my graph solution. Okay, so let's dive in here and let's open Ghost. Just trying to think of where should I do this. Here, GhostGraph. So I'm gonna make it a little bit bigger. So it's really simple. All we have to do is click Create Graph. We name it. I'm gonna name it. Should we name it? We'll name it Slack tips, and then description, aggregate tips from Slack, right? Doesn't really matter so much. We pick the chain. We're doing this on base Sepolia, and we click create index, and it's going to kind of walk us through everything that we need to do to make a subgraph. It's written in Solidity, which is really nice. So a lot of the information that we need is just right here in this contract. So events, we're going to use this tip event, and I can just copy paste my tip event from my contract right into here. Pretty cool. All right. Oh, we don't need any of this, like, any of that stuff. Okay. And I think oh, look at this. I think it fetches your event from your ABI. So if we actually go to get my ABI from my contract, if I go to my constants file, get the address of that tip token, I'll just look at it on Sepolia. Oh, I'll get the ABI from here. Oh, let me quickly verify the code on the chain so that we can get the ABI. I deployed it with Third Web, so that makes it nice and simple to verify the contract. GM Warudo, welcome back. Ooh, my contract verification failed. That doesn't usually happen. That's interesting. Well, it doesn't really matter because we have the event that we need, so that's fine. I'm not going to really worry about that right now. Every now and then, verification can be a little finicky. All right, so now we click this generate code button, and we get all this nice like helper functions. So let's see, this is like all this like helper functions from Ghost in case we need anything. It's almost like a library of helpers. Like we have another one here, really cool. Like string helpers, for example, is really great for like turning a number into a string, stuff like that. But what we want to do is we want to create our indexer. All right, and so there's a few things we need to do here. This is essentially like the magic of the indexer. So first thing is we need to register the contract. So it's not a factory, it's just what they call like a handle. So we'll just take that, and then we actually need that that address. I think it might need to be checksummed if it's not already. It doesn't look to be checksummed. Let me just quickly open it on Sepolia and get the checksummed version here. Copy. Great. Paste. Okay, so we've got that, and now it's really on us to kind of do something when this on-tipped event is triggered. So let me see. I skipped the schema. I'm getting a little ahead of myself. When we're querying the data, we need some kind of schema for what data to return from the GraphQL endpoint. So I'm just going to make it, should we call it like maybe we could use this too to make our leaderboard. I think that would be really cool. Wow. Yeah, I'm doing a lot of thinking, getting a little ahead of myself. I'll probably just keep it simple for the stream here for today. But we could just do, the struct will be a user, I think is probably the right way to do it. And we'll have the string ID. Actually, we don't need that. We could use their Ethereum address as the ID. So we'll have an address, which will be the user address, and then a uint 256 of tips received. I think that's really it. I think like if we're just trying to keep it simple, looking at your tips of all time, we can see that here. When we say like tips received all time, something like, I don't know, didn't really give that a lot of thought. But you could imagine us making like some of the thoughts I had in my head just now were like things like timestamping this so that you can maybe make like a struct that's a tip, and you could timestamp the tips, and then you can like look at your tips. How many tips did you receive last week? How many tips did you receive last month? Maybe we'll do it. I always do this on stream. I always get like a little ahead of myself, and I try to do too much. I'm just gonna fall into that trap one more time. It's the last stream of the year. Tip, we'll say address. Well, now every tip needs an ID. So there's actually some kind of like unique identifier thing, I think, for, it's just a string, I think. Yeah, so struct tip ID, string ID. It's going to, it could belong to a user. That's cool. Yeah, let's do that. Let's do @many tip dot ID tips. It's cool. And that will belongs to user.id. We'll call it tipped user ID. We could call this, maybe I'm going to get really crazy. I'm going to do tips received and then tip.id tips given. Wow, look at all this. Now we're going absolutely freaking nuts. And I don't even know if this will work if we do two of the same like that. Going crazy. Tipped user ID and tipper user ID. Wowee. All right. We'll do a timestamp. You went 32 for time, huh? Isn't there like we're coming up on some kind of like Y2K bug where timestamps aren't going to fit in UN32s anymore? Like 2030 something, 2038 or something. I'm just going to go to 56. Time. Bytes 32 for the transaction hash of where this originated. Beautiful. Oh, we need the amount, duh. So let's put that in here too. Let's put it at the top. UINT 256 amount. Okay, so let's talk about this. Let me get rid of all this comment stuff. This is going to be the like entities in our GraphQL endpoint. So first, you could think of it like a user. So the user is going to have their address. It's going to be like their unique identifier. Then there's going to be a number, like how many tips have they received all time. And then there's going to be tip objects, like the tips that you've received, the tips that you've given. And you could use like GraphQL query things like, first, last, limit, whatever. What am I saying? You could basically paginate over these is what I'm trying to say. So when you're querying it, you won't get like every single tip. Like you can keep it kind of like short. Then you have your struct tip. So this is going to be like, what does an actual tip look like? We're going to give it an ID, the amount, like how many tips were actually given in this one. Yeah, in this like one tip instance, you could say. I'm trying to think, is that like, should we even have the amount? I'm saying it out loud, thinking like, should that just be one? Should every tip just be one? And we make multiple tips. No, I think we'll keep the amount in there. We could do our best to do some tallying. And then the user who that's going to, the tip is going to be here. We have reference to that object, and then the user who did the tipping will be here. I think dot address is the right thing there. And then the time stamp of when that happened, and then finally the transaction hash where that happened. All right. Now, after filling in schema, click end events, click generate. So let's regenerate this. It's been modified. Yep, we don't care about what's happening to index. It'll be already, it'll be fixed. All right, so tip ID does not have a corresponding belongs to, pointing back to the tip received. We don't? Belongs to, pointing back to the tips given. Looks like it does to me. Let's see. Let's check out the docs. Probably doing something wrong here. GM Tarn, thank you for coming back today. And thanks again for your help yesterday. I hope you enjoyed your on-chain gift. Okay. Let's make this a little bit bigger. So in this example, one pair references many swaps. So we use the many keyword. And the swap struct specifies the pair that each swap belongs to. Yeah, so a pair can have many swaps and the swap belongs to a pair. Now, how is that different than what we've done here? An address can have many tips given and an address can have many tips received. A tip belongs to one user and like for whoever did the tipping and whoever received the tipping. So like, what am I doing wrong here? Pair.id. Does it have to be? I don't think it has to be. Oh, it's called user address. I'm getting ahead of myself here. All right, let's try that again. First bug. And it's always because I'm trying to do too much. We're going to get it done, though. Don't worry. Every entity must have an ID property. Well, there you go. Well, there you go. And that's not really an issue. We'll still have the address. Okay, we're still... Tip.id does not have a corresponding belongs to, pointing back to the user tips given. Is there like a way I can... trying to like define like the relationship here. Belongs to should end with an ID if you want the object association. Well, interesting. Tips. Wait, how'd they do that in the example? Pair ID. Okay. Okay, well, I did do that. Tipper user ID. Which can be bytes 32, address, or string. Oh, well, we had the address there. So let's just call that ID. And then tipped ID, how about tipper ID? How about that? Does that work? Tips received. Tip.id does not have a corresponding belongs to, pointing back to user.tipsReceived. Swap.pair ID. Belongs to. Oh, do you have to like name it the same? Do I have to like name it the same? Pair ID. Maybe. What am I doing? Pair tipped ID tip dot I'm gonna call it tipped user and tipper user. Maybe that's it. Yeah, that was it. All right. Cool. Stumbled a little bit, but got there. So now we have our relationship. So set that up all correctly. Now let's take a look at the indexer itself and talk about how we'll actually manage this. So again, just need to take that. I gotta get the checksum again. Hold on 1 second. Register this contract. I wonder if this works for unverified contracts, hopefully. Okay, and then now every time the event on tipped gets triggered, we can do something. So, for example, we can, what will we want to do? I think the first thing we'll probably want to do, let me just go back to we get the sender, the recipient, and the amount. So that's going to be all here in the EV variable. So I think yeah, amount, recipient, and sender comes with it. So I think the first thing we should do is we should get or create the user who tipped this, who initiated the tip. That'll be step one. So let's actually write out what we're going to do here. We're going to get or create the user who sent tip. And then once we do that, we're going to get or create the user who received the tip. And then we're going to create a new tip entity or whatever, a new tip record, capitalize it, tip record for this tip. All right. So first things first, let's get or create the user. So let's say tipper is going to be it's actually, we think about this for a second. I think it's going to be the user. I think that's what we have in the schema. User memory, we'll call it tipper. And that's going to be equal to graph dot get user ID, right? Did we call it ID? Or I think we just called it address. Yeah, we just called it address. So we could say address is ev dot sender. Okay. I don't know if there's like a get or create. Is there something like that? No, I don't think so. So it's just get, and then we could check for whether or not it's nil. I think, right? So, and you get no cursor help in the IDE. So kind of on our own here. If tipper is, I think, what do they use in Solidity? Is Solidity null or nil? Solidity check null. Is there a null-like thing in Solidity? It's set to 0. Let's try this. Let's use 4.0. How can I check if my user is null in Solidity? So there is no concept of null. Okay, so if the address is 0. All right. Sure. So if tipper.address is equal to address 0. Okay, we'll try that. Then we'll say tipper is equal to graph dot, is there a, or we'll just say, let's go back to that. Imagine streaming your browser history, how dangerous that is. Yeah, so we'll just make another user here. Or can we just make a user like this? I think that's how we do it. ev.sender. What else does it have on it? It has tips received all time. Zero. I wonder if that'll work. Something tells me maybe not. We'll see. If no user, create a new one. Okay. Now we're going to kind of do the same thing, but for the receiver. So we'll get the address of ev.recipient. Okay, great. And then we're going to create a tip. So tip memory tip is equal to graph dot, or not graph, just tip. But the ID is, now this is where the Ghost protocol comes in and can do some pretty interesting stuff. So there's a there's like a unique ID thing you can do with I think it's EV, no, it's what's the other thing? Details, I think. Details dot unique ID. I think that's how you do it. So now we can give every tip object a unique ID. So what else does it need? It needs the amount, time, and the transaction hash. The user. Let me just bring this in here, where I can see it. Okay. So we're going to need the amount, and that will be from the event, the amount, and then tipper user ID is going to be, we have these in context here. So, oh, and I gotta call this tipped. Tipper dot ID, and then tipped is going to be tipped user ID is going to be tipped dot ID. Let me just put these in the same order that they come back in the struct with. Tipped and tipper. Okay. Now the time is going to be details dot timestamp, and the transaction hash is going to be details dot transaction hash. All right. Now, if this doesn't compile, I bet it has something to do with the way I'm creating some of these things. So let's see. Oh, wait. I always forget to do this. Graph.save. So we need to do graph.save tipper. And we need to do graph.save tipped. And we need to do graph.save tip. All right, I always forget to do that, so thank you for the reminder up here. Let's compile this and see what happens. Let's see what breaks. Boom. Expected identifier, but got address. Did we call it some? Oh, we called it ID, but it is the address, the ID. Now, do we also call it an ID? Yeah. So here we'll call it ID. And then here we'll call it ID. So we just need to call it ID and not address. But we still save the address. No, we don't. We just save the ID. So one and the same. Yeah. All right. All right, let's try that again. Line 50, I have a missed semicolon somewhere. Line 50 here. Love that. A missing semicolon bug. Member save not found nor visible. Really? Seemed to be pretty found and visible before. Graph.save tipper. Oh, I have to save like you have to tell it what kind of entity it is. So it's save user. And does it autocomplete that? Save user. Yeah. My bad. Save user. And then there's save tip. Graph.save tip. Okay. Now let's try compiling. And we've got a successfully compiled subgraph here. Now, before we deploy it and use it, let's just take a look at what it's doing and kind of recap. So anytime that this event is triggered from my Solidity smart contract, this graph, this indexer is going to pick that up, and it's going to run this code. So it's going to either get or create the user who sent the tip based on this value here, sender. And then it's going to get or create a user who received the tip based on this, which is the recipient. And then it's going to create this entity, or this record that we've defined ourselves for our subgraph called the tip. And it's going to give it a unique ID. It's going to take the amount from the event, and it's going to tie it back to the user objects that we created above, and some other information like the time and the transaction hash. All right. So deploying this is actually easier than you think. It's you just click deploy, and you click confirm, and now it's indexing the chain. And any moment now, we're going to have a URL to use. So actually, let me bring this out of view for a second, because I think that the URL contains an API key. So let me just quickly, yeah. Well, it does contain the URL, which is not so bad, I think. It does not share an API key. All right. So we've got our subgraph created. It's out there, and it's totally synced. It only took 7 seconds to sync this thing. So let's go into the app, and let's start using this. So off screen, I'm just going to update my environment variables here, and I'm just going to make one called Ghost API key, and I'm going to make a Ghost API URL. I don't yet have an API key for this, so let me just quickly make one off screen. I think I gotta go back, create API key, generate, copy. Okay. Okay, I can bring this back. Here, I'll just paste that in my env file. All right, cool. So now we're ready to start consuming this subgraph, which will be easier than it sounds. So let me just quickly update my the environment variables that we need. We're going to need the Ghost API key and the Ghost API URL. Same thing here. All right, cool. All right, so let's let me think about this. I'm thinking about like where should we make like another library file called Ghost, maybe ghost.ts, and let's export a like a get all-time tipped count, and then this will take an address, which is a string. Oop. Maybe it'll fix that for me. Yeah. Wow. Okay. Wowee. It did too much. All right. All we need to do is it's doing too much. This is it's almost correct. Let me tell cursor. Trying to think of like the Ghost API is a GraphQL API. We will want to. Oh, I think there's a playground I can use. Yeah. Yeah. Does it come with anything pre-baked? This is, I think, maybe from some like older. This is from the on-chain gift app, I think. I'll call this get. What do you call it? Get tips. Well, we'll have Cursor do it for us. We will want to query the API to get tips. I wonder if I can give it the schema. Here is the schema. See how much it can actually do with only that much information. It's not a ton of information. Let's just see what that would look like if, whoa, if we cut and paste that. Let me go back to my Slack. Look at this user. Unknown type ID. Let's just call it like this is just a string with a capital S. Okay. I wish I could tell you what I'm doing here. All right, let's just accept all of this really quick and see what happens here. Let's make a test endpoint that takes in an address and calls the get all time tipped count. Actually, no, we could just do that with the existing interactivity endpoint. We'll just have this instead of saying we want, where's that homepage thing? Slack. Total tips received is now going to be not the balance, but get all time tip count from the address. And I'll just console log the balance so it doesn't. All right. All right, and then here, it's just like log out what we get. I'll do a JSON stringify data. And I'll just do my little classic fire emoji or something. Okay. All right. Let's go back to Slack. All right. So it's logging literally that stuff. Let me just say like user data. I want all the data here. Okay, so yeah, we're getting all kinds of weird stuff. Does it have like an items thing? Get not like the greatest with GraphQL yet, but I want to get better. Let's see. Users where ID looks like that. What if we don't even do a where, we just look? Yeah, that's sus. Getting lots of errors. What do you think of this query? Can I add all this to Composer? Still probably gonna get some errors. We'll just see if we're getting any closer. Wait a minute. Yeah, we're not any closer. Let's see. Oh, it got rid of my fire emojis, that's why. Put my fire emojis back. Rapid and fire. It's getting actual data back. Well, that's good news. Now it doesn't say I have any tips. To be honest, I don't know if that's true. I forgot if I did that. Run the query and error in GPT. Should have done that. I wish I looked. Timestamps are off, by the way, Tarn. I don't know what's going on with, I don't know how long ago you sent that. Sorry if I haven't seen it until just now. All right, I could try doing a tip and seeing what happens. But actually, let me just take this query. And instead of doing the filtering, I want to get them all. All right, yeah, so this is worked. What's going on here? I wonder what's up with that. What about this? Oh, okay. The variables mattered. All right, so yeah, none of the users have tips. That to me sounds, oh yeah, that's wrong. Maybe we didn't update that correctly in the indexer. Let's just take another quick, fresh look at that indexer. Where the heck did I put it? I think it's over here. Are we actually, like, are we incrementing the total amount for the tipped? No. No, we're just saying it's 0, which is not correct. So what we need to do, and while we're here, maybe it's cool to do like a tips given all time. So why don't we add that if we're going to be making changes? Tips received all time. Whoa. It's a read-only editor. Uh-oh. Yeah, so that's one of the things. Once you deploy it, there's like really no going back. You could fork Slack tips subgraph. Okay. Slack subgraph. So you could fork, but once you deploy, that's it. That's a wrap. But the error that we have right now is our total received all time is never changing. We're never updating that. So that's not good. We need to do that. And so I was thinking, well, while we're here, why don't we just add a uint 256 tips given all time. All right. So let's do that. Generate indexer. Here, instead of this, we're going to have to say, like, before we save the tipper, we're going to say tipper dot tips given all time is going to be, is there plus equal? I think there is. What about just plus plus? No, plus equal amount. Yeah. The amount, because this could be more than one at a time. Okay. And then here be tip dot tips received all time. It's going to be ev dot amount. Cool. And then I think that this here is going to take care of the tying of the objects. So let's compile that. Uh-oh. Wrong argument for constructor. 2 arguments given. Expected 3. Oh, because I have to initiate that at 0 for tips received and tips given. Tips given all time is also 0. And then up here, same deal. When you're initializing the user, tips given all time is 0 because we've never seen you before. No trailing commas, I think. All right, let's compile that. Great. We'll deploy it. Confirm. Perfect. It took 5 seconds to do that, which is cool. Let's borrow this query from here. Run it. Yeah, that's much better. And yeah, we're going to get 18 zeros at the end, but that's fine. Let's also get tips given all time. What's going on here? Tips given all time. Yeah, nice. And then the front ends would just, convert that from way to ether. The object, let's see if the objects are getting tied correctly. ID, tip user, tipper user. So I hope you could see like how awesome this is when it comes to like doing stuff with your data with smart contracts and graphs. It's pretty sick. Tips given, and then we'll do tips. What in the world just happened? Oh, there we go. Tips received. We'll just copy this. Yeah. So now we get like tips given. You get everything that happened there. The user ID, who you tipped, who got tipped, right? Check this out too. You could also do a timestamp and the transaction hash where it happened. Here we go. Right? So if you want to like sort things, you do that. Looking good. That's right. Looking good. So let's go back to this. We're getting tips received all time. This should actually work now, but before I forget, I need to get the new URL, and this does not show the API key. Correct. It just shows the URL, which is fine with me. Here, I'm just going to throw that into my env file off screen. Cool. Come on back. All right, so now when we look at our Slack page, this should actually show where my fire. Yeah, look at that. So now it's a lot, but we're gonna convert that. So maybe instead of sending it back just plain old like that, we'll convert it. Let me think. Why does it? Oh, it thinks like maybe it doesn't get a user back. We could just send the way around, and then here we'll do this. We'll do where do we actually total tips received? We could just say to ether. And does that give it to us in? It's expecting a big int. Okay, and does this give it to us in a string? Yeah. Okay. So now coming back, that should turn to a 4. There it does. That's cool. So we just used, oh, and like, oh no, you have this many tacos to available. So yeah, so now we're actually using the subgraph to get the total amount tipped of all time. And the reason we did that with a subgraph is because using the balance isn't good enough. If they withdraw their tacos somewhere else, then their all-time number is gone. Like if they withdraw their tacos, then using the balance of their tacos is not going to cut it. So this uses the events, the tipping events, to count how many times they've been tipped all time. Now I'm looking like here, there's a little bit of a bug. This is still using your balance, which it should, because this is telling you how many tacos you have to withdraw. But let's just update that. So let's just see down here. You have total tip received, available to withdraw. That's not actually true. We want to see your balance. And I think we kept the balance around. We did. It's here. Get rid of this. Down here, we're going to show you your balance. I think that already comes back in ether. .display value. Okay, there it goes. So if we show you that, 1 taco. Do we have anything else? 1.0? I don't want to. What was I using? Display value? I guess display value is fine. It just feels weird to have like a decimal version of your taco, but I guess you could. Balance dot. I don't know. Why don't we also just take the value to ether? Balance dot value. I think that's in way. And then, yeah. Okay. Just making sure you're gonna get the sandwiches. Yeah. So wife is texting me. I said I gotta get off in 90 minutes, and I'm going to. I'll just put her heart at ease. I am doing it. Don't worry. Okay. So now we fixed the balance. We fixed the total tips all time. So it's actually interesting because this user has 1 taco in their address, not 4. So if I try to withdraw 4, this should error. If we go to the engine, this should error. Refresh this. So it might not even be making it to the engine. Let's see. Did I click it? Oh, we'll do the happy path because maybe I didn't think we were smart enough to not send it. Let's do 1. Oh, what's it say? Withdrawal address or amount is missing. Oh, No withdrawal amount. Input.value. What? Oh, I didn't put an address in where to withdraw it to. That'll do it. All right, so at least we got some form validation on that. That's good. Put the address in, and then I'm gonna do that same thing again. I wanted to demonstrate if I try to withdraw 4, because that's how many tips I've received. That should not work. But then withdrawing 1 should. All right, great. That failed 3 seconds ago. Now let's do 1. Let's see if it withdraws. And it looks like it's going to go through. So yeah, that's pretty sick. And using the graph protocol, so the Ghost protocol to use subgraphs is pretty simple and straightforward, which is awesome. Let's just take a look at that on the chain. There you go. Sent 1, and then this balance should update to 0. 0 tacos to withdraw. Looking good. Looking good. And then let's just see how fast it can update if we give out more tips. So I've sent out 2 tips today. Is that right? So if I go to my tips channel and I'm gonna tip Mike. Great job, Taco. This should do. There we go. Just sent my tip. Sent 3. That's great. I forgot how many total tips I had all time. Was it 2? I didn't pay attention. Let me do this. Well, let's look at we got rid of the console log. It's fine. I'll do it one more time. And let me do it with a different user. Do it with this user. And I'll make it bigger for you. All right, so how many tacos is this person received 1? Oh, they sent out 4 already. Means I can only send 1 more. I wanted to kind of do the test with 2 at a time. I think this will be fun. Oh, I sent 3. All right, so I have 2 more here. All right, let's do it. Let's do 1 more. I'll go here and I'll say Mike Paul. Mike Paul. Good job. I'm gonna send 2 tacos. And before I do that, just one more time, I want to check. It says total. Oh, this is receiving all time. Oh. Yeah, so hold on. Let me go here. Total tips received all time is 4. This should send 2. And then this should pop up to 6 in a second. Oh, it failed. No. Wait, why? Did I send too many? Oh, because you can't send, sorry. You can't send 2 to each person. That would be too many. I'm just gonna send it to that one user. Taco. Good job. All right. This is actually working, which is great. It's like doing it. It's honoring the constraints correctly, which is good. There's my tip. Did this bump up to 6? It did. Wonderful. This 5. Great. Incredible. It has 2 tacos to withdraw. All right. I'm feeling really good about what we accomplished here in the hour. Gonna quickly push this. And yeah, so let's just kind of recap it for like a summarization here. So we used Ghost protocol, or sorry, the GhostGraph protocol. I'm gonna ditch this, the broken one. Just want to make sure I didn't ditch the wrong one. 2. Okay. Cool. So we use the graph protocol to make a subgraph, and you do that with just writing Solidity. So because we have a contract that's emitting events that we could use to kind of like save somewhere, we can use those events, do some aggregation here. So for example, we were showing you how many tips you've received all time, and every time that there was a new tip, we would increment your tips received or your tips given all time. And we would store all that information about your tips here in a subgraph. Now on your front ends, whatever you're using, I'm using Slack as a front end here, you could display that data by writing GraphQL queries to your GraphQL endpoint. Pretty cool. Trying to do this without a subgraph is way more difficult on chain. So I think this is like a really cool solution for that kind of thing. So shout out to GhostGraph for this. It's a really cool tool. Maybe you could try using it for your next project that you need to aggregate some on-chain data. All right, folks. Well, I hope everyone has a happy new year. It's been a great 2024. Thanks for hopping on the stream with me today. Appreciate you. Take care.